Good morning. Welcome to this Dive project. My name is Cédric Gilon. I'm part of the AI coordination unit from the IT department from the Université Libre de Bruxelles. And today, with my colleague Yann-Aël, we present you an introduction to general artificial intelligence. So let's dive right in. And I wanted to start this presentation by trying to give you a small definition of what artificial intelligence is. And I think we can base this part on the new European Union Artificial Intelligence Act that has been released in June of last year. So in this definition, we find a few parts that are interesting. An AI system is a machine-based system that operates with varying level of autonomy, and it receives inputs and generates outputs. So that's a few parts that we can take with us from this definition to try to work with to define what AI is. So if we look at the history of AI is not new. Actually, it started somewhere in the 1950s with the first attempt to generate software that operates on its own, receiving inputs and giving out outputs. And then in the 1980s, a subpart of AI started to rise, which is called machine learning, and is the use of large amount of first data and then large amount of data to try for the computer to learn on its own. A bit later, in the year 2010s, appears the deep learning, which is a subpart of machine learning, where machine learning algorithms has been changed around artificial neural networks. And finally, what we are discussing today is generative AI and large language models, called LLMs, that appear in the end of the year 2010s, around 2018, somewhere like that, and has been rising since then. So artificial intelligence is actually around us in everyday life, from simple AI system to more complex AI system. So if we look at, for example, system that we are playing against in chess or in Go, those are AI system, but also like the AC unit that you may have at home, or recommendation algorithm that you have on Spotify or YouTube or other platforms. Search engine are some kind of AI, and then you have the more complex, which are weather forecasting, autonomous driving, and the last one, which is the one we are talking about today, is about generative AI and LLMs. So speaking of that, how do we define generative AI? So generative AI is a part of AI, which, so we, in the definition, we were talking about inputs and outputs, and that's how we really should be looking at those models. So in this case, we have an AI model here in the middle, which receive prompt, which is a text, some sentence, and then it will generate something based on that. It can receive text and generate text. It can receive text and generate images, or it can receive text and generate music, for example. So if we look at a model of generative AI as ChatGPT or Microsoft Copilot Chat, those models, you have in front of you a chat window. So you write a sentence, and then the sentence is sent to the models. So the prompt is going from the user interface to the model, then the model processes the sentence and generates some text in response. So this is a black arrow coming back. And then the user can, building on that, ask some other question. So the new question with all the previous content is sent to the model, and the model only generate some text based on that, and this is the next answer. So we have really here going from the user interface to the model. So we are giving text and receiving text in response. But sometimes user interface can hide a few models. So if we send text, the model can send text in response. So we have here, for example, a model called GPT-4, which is a model from text to text. It receives text and generates the text in response. But also, under the same user interface, we can have another model hidden. So we can ask the model, could you generate a logo for the Dive project? So it's sent to the model, and it's another model that will be hidden here, which will be taking as input text and generate images as output. So here we have a nice logo for the Dive project that you are part of this today. As I was talking previously in the beginning, so LLMs and generative AI is a subpart of deep learning, which is a subpart of machine learning. So how does machine learning work? What's here under the hood? So to have machine learning, first you need data. You need to collect and process data about the subject that you want to create a model around, and you need the largest possible amount of data on that model. And then you need to use that data to train a machine learning model that will optimize the parameter of the model to minimize error using the data. So the model will try to use the data you provide to create and optimize some representation of the data to generate the output you are expecting. And then the last part is the inference, where the model is trained, the parameters of the model are fixed, and the model is used to generate text. So my colleague Yann-Aël will now take some time to look with you to create a small model based on image data processing.
Let us see in this demo how we can have a model recognize images. So for that, we'll use the Teachable Machine by Google, which allows to do exactly that. We'll create a training set, so a set of data that will be used for the training, and we'll have the model recognize whether I'm raising my left hand, right hand, or no hand at all. The first class will be left hand, and by clicking on webcam, I can take examples of me raising my left hand. I do the same with the second class, calling it right hand, and taking examples of me raising my right hand. And finally, I add a class no hand, where I'm not raising any hand, and it's just my face. But it's better to have around the same number of examples for each classes, and once you're done, you can train the model. It's here on your network that we are fine-tuning, so it's going to be pretty fast. And once the model has been trained, we can see here that it's correctly recognizing that I'm not raising any hand. And if I raise my left hand, we have that the model is pretty sure that I'm raising the left hand. And if I raise the right hand, it's also pretty sure that I'm raising the right hand. And what's important to see here is that it's about probabilities. So the model is predicting probabilities for each of the three classes, and the accuracy of the classification will depend on the quality of the training data.
So my colleague showed you how how the model can be built using a small data set of images. So the model receives as input an image and output some prediction of if the image happens to be from one category or the other. And for a large language model, what does happen? Actually, large language models are models that just try to predict the next word. So they receive a sentence as input and try to predict the next word, as you have on your phone keyboard. So when you are writing, like the Dive project is, and then there is a blank space, and the keyboard tries to say, okay, maybe it's done, it's fantastic, it's D. So you have here a few options, and the model tries to predict the next word. As an example, so if we have here in the sentence, in the center, the generative AI that take as input the prompt, so the text inputs. I took the kids to the And then the model will try to predict what can be the next word. Is it I take the kids to the zoo, to the beach, to the library, to the park, to the pool? All of these words can sometimes happen in a sentence or anywhere else, but the model has to decide which one it will take. So here again, my colleague Yann-Aël will look with you at how those predictions are selected under the hood for the model.
The model which is inside a large language model is called the transformer. And this interface, the transformer explainer, allows us to see what's happening inside the large language model. So basically, there is a sequence of words or tokens which are provided as input to the transformer, and the transformer will transform, so make a set of computations, in such a way that it's able to predict what is going to be the most likely word or token as output of this input sequence. So there we have data visualization empowers users to and visualize. So let's enter there the sentence that Cédric was giving just before. I took the kids to the, and then ask the interface by clicking on generate to predict what is the next word or token. So we see all the computations there, and we see here different options, and we see that the one with the highest probability was park, but it's local, which was chosen by the model. And so it's interesting there to point out that we have this parameter called the temperature, which will decide how curious the model is in picking the next word here in the different possibilities. So these are categories, exactly in the same way as we had categories with image classification. And the model here chooses one category which is not the highest probability because the temperature is a bit high, but if we decrease the temperature, the model will go and pick the category which is the most probable, which in this case is park. So it's thanks to this parameter that we can have the model being more or less curious and more or less creative in a way in choosing how a sentence is built word after word.
So you have seen how the models collect those predictions under the hood. So we can ask ourselves, okay, but how are those predictions selected? So if we look at, for example, a sentence which is my favorite color is, and then we ask the model, could you finish this sentence? And then the model can output something like my favorite color is blue, a common favorite. And we can ask, what does it mean, a common favorite? So if we look at the data on the choice of color around the world, we can see that in a lot of countries, actually, blue is the most represented color when we ask the people what are the favorite color. So here the model is predicting what's something that it has been trained on. So the data in which the model has been looking for during the training contains most of the time when we are speaking about color that blue is one of the favorite colors. So when we ask what's the favorite color is the most probable the result with the nicest probability is that the color is actually blue. So I was talking about the training data. So what's the training data that is inside these machine learning models? So we have some text that is selected from websites, from Wikipedia, for example, from forums, and from books, and all of this data is input into the model using the machine learning. So it is selected by a designer and developers that try to exclude protected and content protected by intellectual property, try to limit false information that goes into the model, because the model, if it is fed with a lot of false information, will predict that the next word is probably also false information, and they will try to remove hateful or discriminatory content. And for large language models that we are talking about today, we use billions and billions of documents and web pages and articles that are fed into the model to learn, okay, the most probable next word is this one or this one. And the model learns, okay, when I have this kind of sentence, the next word will be this one or this one. So what are the consequences from this? So we have here a generation of probabilistic of the next word of what is the most probable next word. So we have here a few points that we will that we should look at. So when AI is predicting the following of a sentence, it may not always choose the same word. So when you ask the same question twice to a large language models, it is expected to not have twice the same answer, because the probability will maybe change a bit because you didn't write perfectly the same. And so the answer of the models can change from one question asked at one time and the same question asked later. So the next point is that AI do not have notion of truth. They just try to predict the next word, so there is no truth or false. So if an AI is fed with false information, the most probable result is that false information. So they will try to it will be expected from them to predict those next words. So they do not have notion of what's true and what's an error. And so that's actually the next point. They can generate errors. They can generate content that is not true, that should be corrected. But if this information is contained in their training data, they will actually output the same errors in their output. And the last point is that AI are actually not neutral. They reflect the training data. So if there are bias, if there are errors, if there are missing parts in this training data, the models cannot like generate new information around that. They can try to predict something that is the most probable, but it may be difficult to create new ideas if it's not present in the training data. So here is 3 points that we should look at. So AI models are weird, which is the abbreviation of Western, educated, industrial, rich, and democratic. Because most of the content that is fed into those models are following those five directions. So my colleague Yann-Aël will for a last time look with you with a tool called tracking AI, which is looking at those direction for those models.
This is the Tracking AI website, which is designed by Maxime Lott, a journalist from the United States. And it's an interesting website because every day it asks a question to the main chatbots, LLMs, that are currently available. So that's going from GPT-4 to Bing Copilot to Claude to Gemini and so on. And it's trying to see what are the political values of these different LLMs. And the question today is, no broadcasting institution, however independent its content, should receive public funding. So quite a strong statement in terms of freedom of expression and how the government can support like different voices to be heard. And it's interesting to see that for this question, all the chatbots there, from Grok to OpenAI to DeepSeek, they all disagree. So they all think that indeed there should be some public funding for broadcasting institutions. There is a bank of questions which is available there. See every AI answer. And there we can choose questions from the bank and see, for example, No one chooses their country of birth, so it's foolish to be proud of it. And we'll see that there we can see differences. For example, Grok 3 disagree, and this is going to be the same opinion as OpenAI. So answers can be quite long. OpenAI will also disagree to the question, OpenAI models, but we can see that Llama 3.3, so Claude, for example, Claude 3 agrees. While having pride in one's country can be a positive force, it's essential to recognize that our country of birth is a circumstance beyond our control. So interesting to see how different models have different opinions on such statements.
So the second point here, after what we just showed you, which is like the political direction of those models, is that the data protection. So when you are writing to ChatGPT, Microsoft Copilot, or other models, the user data can be collected, can be saved, and can be reused later to train other models. So you have to be careful about the data protection and what you are inputting in those models. And finally, the last point of the limit we want to look at is that the environmental impacts of those models is huge, actually, because they need huge infrastructure to run those large language models. So the use of those models have really an impact, and we should look at the benefit and cost of using those kind of models. The last part we want to look at is the usage in higher education. So here is a few ideas that you can look at. You can brainstorm idea, you can translate, you can create schedule, all of that using those models. So the thing that we want to really push you is to experiment. So put your hands on those models to try to do all of those tasks and to see how the model reacts, keeping in mind that the model is only trying to predict the next word. So there are limitations on the models, but still they can do a lot of stuff. The next point in the usage in higher education is to look for guidelines if you are using LLMs from your institution, for example. And also look for policies in academic journal. For example, here on the right are the policies from the New England Journal of Medicine about the use of AI-assisted technology when writing a manuscript. And a lot of actually journals are making a distinction between the use of AI in manuscript preparation and edition, like correcting typos or correcting grammatical issues, and the AI used during the research. They are making a distinction between the two, and you have to be aware of the distinction and what you can do, what is appropriate use for those tools, and what are not. So the last point, so the last slides of this presentation are actually a few conclusions, a few take-home messages. The first one is that generative AI, so that's really the message that we want you to take with you, is that they are using probability and autocompletion. They are trying to predict the next word, so there is no reasoning inside those models. There is no reliability, no truth. There are only models that are giving as input a text and predicting text as output. The second thing that we did, and we created a list of few tools that you can play with, is that you need to experiment. If you want to put your hands in those models, try to explore a few differences, try to see how does one react best when you are working with them, and which one give you the best results. So experiments in the area where you feel comfortable with, and where you will be able to see if the model achieve what you are looking for, and what if there are errors in the prediction. And the last part, as we discussed, there is a few points to watch around these models. The first one is that there is bias. The model will be predicting the kind of words that is included in their training data that include bias, and we should be careful around that. The second one is that The data protection, so if you're using a free model, there is a high probability that the company may keep your data to train other models, so be careful with information you are inputting in those models. And the last one is reliability. Do not use these models as like a source. Cross it with other source. Try to use it as a tool, but not as a reliable source that you can fully lean on. So I hope that you learn a lot of things in this presentation, and wish you the best for the continuation of your dive seminars.